Okay, so we're picking up where we left off on lesson 2. This is page 234, and we're going to do perfect square factorings. So in order to do that, first we're just going to do a perfect square expansion. And what do I mean by perfect square? It means that the trinomial, see this is that structure we always have, right? So when you factor it, you get these two terms. Do you guys agree? And there's like, you know, the two terms in each one. It could be plus or minus, whatever, right? So, you know, something involving x and then some number, like number 1 and number 2, right? And there might be some coefficients in there, right? So what happens when these two things are the same? Well, they call it a square. Why do they call it a square? Because the length and the width are the same. Okay, so it's a square. Okay, so what happens when we have a square is these nice little patterns. Okay, so let's take a look at what happens when we square this. So just above this, just put the two terms, because that's what the square means. It means repeat the factor twice. Okay, and then we'll FOIL this out, and hopefully you catch the pattern. So p times p is p squared. Now you're going to work into the middle, so you have to do the inside and the outside. So you got a PQ from that one. Then you do it again on the inside, another PQ, and then the last one is Q by Q, which is Q squared. So what happens to that middle term is it doubles up because it's identical. It doubles up. Now these perfect squares, they're going to be so important to us in a little bit here, later on in the month. We're going to be doing these this like special type of algebra, and we have to know these perfect squares. So when we're working with our quadratics, there's this nice little technique. Okay, so we got to be good at this. So you may have seen it in 10C, you may not remember right now, but so we showed it in 10C, you're getting shown it to it again, and it's very important, this stuff, for a later topic. Now what happens if you do the exact same formula, but instead of a plus, it's a minus? Everything's the same except for the middle. Instead of it being plus, it's minus. Now the first and the last are going to be positive as well. And you could FOIL that out to confirm it for yourself. Okay? So it says the first term in the trinomial is the square of the first term in the binomial. The last term in the trinomial is the square of the last term in the binomial. And then the middle term is the product no, we gotta switch. I hate underlining my bad, is double the product of the first and the last terms in the binomial. Okay, so if we look at this perfect square trinomial where on the stop note here, it says the first and the last terms must be perfect square. So let's highlight that. The first and the last. Okay, so the first and the last must be perfect square. So in this example, is x squared perfect square? Obviously. What about 25? Yeah, it's 5 by 5. And then it says, okay, in order for this trinomial to be a perfect square, the middle term must be twice, I guess I put double, but same thing, twice the product of the square roots of the first and last. Okay, so what's the square root of x squared? X. What's the square root of 25? 5. Multiply those together, you get 5x, and then you double it, and it becomes 10. And the reason it doubles is because it happens twice. It shows up twice. Okay, the other thing that you can do is sort of connect it to how you've been doing decomposition. So I'll put that in there as well. This is another strategy, because a lot of people might not They might not stumble upon the pattern here during a test or something. So if you do decomposition, and you know how you have to find those two numbers that work out? So what are we going to call those numbers? Can we just call them magic numbers? So you remember what I'm talking about? The magic numbers will be the same. So let's take a look at what that might look like. So let's take a look at the first one. What multiplies to 4 and adds to 4? 2 and 2. So if you get the same number, it must be a perfect square. Let's take a look at the next one. Does it meet our requirements for the next one? 6 is not a perfect square, so we can't do this one. How about 81? Okay, so does this have a GCF? No, 81 won't divide by 4. So what do we do? Does 81 divide by 4? No. So if we were to just do this one with decomp, because the A is not 1, you'd have to go 4 times 81 is, help me out, so 324, and multiplies to 30, or adds to 36. So you'd have to break down 324. What multiplies to 324? Too many, right? So for this one, going with decomp, it's like, wow, I got to think of all the numbers that multiply to 324. That's too much, right? This AC value and this B value. So there's got to be a better strategy. Yeah, because that's because you know, though, right? You know you should square root that. You got some good intuition there. The best way to do these questions is to spot the pattern. So you see 81, you see 4, you're like, oh, okay, this might be a perfect square. Because this strategy just, it could work if you had some resilience, but it won't be the fastest method. So cut 4 with a square root, you get 2. Cut 81 with a square root, you get 9. Times those two together, 18, and then double it, you get 36. If that's this, then it's a perfect square. And then we can just get the answer. So it's 2x and 2x. It's 9 and 9. You guys agree? Because 2x and 2x will make your 4x squared, and 9 and 9 will make your 81. And then how do we make the middle term negative? They both have to be negative, negative. Yeah. So we've seen these brackets when they're identical. If they're plus and minus, it's a difference of squares. If they're both minus or if they're both plus, it's perfect square. And if they're minus, the middle term's minus. If they're plus, the middle term's plus. Okay, any questions on what we just talked about? You get this perfect square business? Rafi, you need to be on that right now? Maybe put it away, buddy. Okay, let's do the next one. Does it meet our requirements? This one I'd just probably go with the AC thing, right? What's AC? Negative 16. And what's B? 8. What multiplies to negative 16? 4 and 4? So, but it would have to be 4 times 4 would be positive 16, so it can't be that. And minus 4 times minus 4 would be minus 16. Or I mean, sorry, 2 negatives make a plus. So does this one meet our requirements? No. This has to be positive, right? Has to be. So this one was trying to trick you. 8 and 16, yes, those are the right numbers, but the signs don't mix up, or the signs don't make sense. If the question was just y squared plus 8y plus 16, then yeah, go for it. You could do that one. That one's quite simply y plus 4 all squared. Do you agree with that? So that's good. But this one over here is a no good because of the negative there. Okay. Okay, fill in the blank so it will work out to be a perfect square. Okay, so square root 100, you get 10. Square root 1, you get 1x. So times these two together, what do you get? 10x and then double. So this would be 20x here. Oh, so is this the exact same one? Except with the minus? That's okay. Now C, make this 5x, make this 6. Times them together, you get 30, and then you got a double for 60. So hopefully you guys get this pattern. Oh, this one's weird. We almost got to work backwards on this one. So we know the 9 will make you a 3m. And then we got to, instead of, remember we were doubling? Well, let's work backwards. So we cut in half. You get 12m. So how are you going to multiply by something by 3 to get 12? So it has to be 4. Wouldn't you square it? So it'd have to be 16 in there, right? Great observation. Keeping me on my toes. Yeah, because it has to be a square in the trinomial and the square root in this work underneath. Okay, so let's just straight factor them now. You look at this, and again, I always try to relate this to like a test situation. You're like, get this question at random and it says factor. You don't know if it's a perfect square, because you know this one's a perfect square because it's in the perfect square section of the book, right? So what happens on a test, more importantly? So you got to be able to spot perfect squares. Okay? So can you do that? Do you know 49 is a special number, right? And that's something that I can't like teach into you guys. So you got to just kind of have some number sense. So this one will be 7x if it works. And then what will this one become? Square root of 1 is just 1. And then to make a minus in the middle, these both have to be minus, right? And if you're not sure, double check. This is going to make 49x squared. Minus 7 and another minus 7 will make minus 14. And then a positive 1, so this is good. Remember, you can always double check your answer with distribution. Okay, let's see if this one will work. 16 obviously would become 4, and 25 would become 5x. Repeat that. Is the middle term positive or negative? Okay, so these have to be positive. And then just double check. 4 by 4 is 16. Now the outer and the inner, it's going to be a 20x plus another 20x, so good. And then the last one is good. Oh my gosh. This one looks crazy. Okay, what if it just said 9a squared? What would you do? You'd go to 3, but it's not 9. It's 1 over 9. So instead of 3, it's going to be 1 over 3. Okay. And then what about this one here? That's just 3, right? Okay, repeat it. I did put that. Oh, I wrote B. Okay, the middle term is negative, so these two have to be both negative. Now let's just double check. A third times a third is a ninth, so that one's obviously good. Now I'll do the outer and the inner. A third times 3, well that's just minus 1. A third times 3. Then it happens again a third times 3. So again, 2 minus 1s will make minus 2. Then the last one is a plus 9b squared, so that one's good as well. And then with all these guys, you can write it just a little bit cuter for all of these. You can write with just the square. Like that. Okay, so I'm going to give you guys some time to try this, probably about 15 minutes. So at when the clock hits the 1, 5 after, we will take up the next lesson. So for the homework right now, you should have already tried 3 and 4. And you guys are, hopefully you tried 3, 4, 5, 6. And we got to find those perfect squares. So 7 should already be done. So it looks like the perfect squares are 9 to 11 in the homework. So everything up to 9 should, be somewhat partially done. You've given it an honest try. Yeah, I mean, you don't have to do everything, but you should try your best. So you got about 15 minutes to do 9, 10, and 11. I'll walk around and help. And then we'll take up some of the next lesson after this. Okay, so lesson 3. This now finally we're going to get into some more advanced factoring. And it has the same structure. You can see the same structure with the, it's the same, you guys. It's just looks a bit different. So it's still this ax squared plus bx plus c structure. But instead of having x there, they have like a whole new function. Okay? So instead of having x, it's a separate function, and the function has to repeat itself, or else this process doesn't make any sense. Okay, so let's take a look at the first example they give us. Is here. So right here is x4, x2, and 6. So they have to do a little substitution to make it look like the structure we need. So they say, well, substitute in x squared. And you can see they did that there. So it's kind of hard to often spot that pattern as well. Okay, and then it just comes down to, like if it looked like this, a squared plus 5a plus 6, I'm sure you could do this one no problem. Like what multiplies to 6 and adds to 5? It's just 2 and 3, right? Multiplies to 6 and adds to 5. And then down here basically it shows that. So this would be like a square, and then the 2 and the 3. Okay, so let me try some of these with you. And what you'll see is this pattern here. Okay, my screen is freezing. Oh, because my arm is on it. Let's take a look at these ones. The 4, and the 6. What do you notice about those? Are they even or odd? Even. That's the only way they're going to be able to do that. And then if you notice the second power is half of it. See how that works? So this is like these, I use the word contrived. Like these examples are just like they come up with them so they work out perfectly, and you can be able to spot these patterns. Okay. So we're going to do a substitution where you use half. And then what I would do, I would actually say, let this little a squared be big X. Whatever. Do a substitution. Then it's quite simply big X squared minus 5 big X minus 14. Can you guys do this? Absolutely you guys can. It's just getting to that substitution. So what multiplies to 14 and adds to 5? Good, 7 and 2, and then decide on the sign afterwards. So it's going to be big X 7, big X 2. Now which one's negative? The 7. And then all you got to do is resub in what big X was. What was big X? A square. And then just double check these two factors. Could I keep going on these ones? You know, if that 7 was a perfect square, could I keep going on that term? Yeah, because then I'd have a difference of squares in there. Okay, so it's just the same stuff, but with a substitution at the beginning. Okay, so let's take a look at this next one. Let's let, I don't know, big Y equal x squared. So here's the pattern. It's like use half the power for the substitution. Because basically, well, it's not half always. It's not always going to be half. Well, yeah, it is always going to be half. Why is it always going to be half? Because what's the power always going to be? It's always going to be power 2. Like ax squared. So if they give you like 8, what should you use? 4. If they gave you 16, use 8. It's always going to be half because you have to end up squaring it. Okay? So let's substitute in our x squared because you have to remember the power of a power. Do you guys remember that exponent law? Power of a power? What happens when you have a power of a power? No. You multiply them. Power of a power, you multiply. So that's why you always have to use half. Because that 2 is always going to be there. So you got to use half the power because that 2 is always going to be there. Now let's substitute in so it just looks nicer. We got a y squared plus a 4y minus a 5. So how's this one going to work?
Please excuse the interruption. Could all grade 11s with their last names H to L please go get your picture taken by the bleachers? All grade 11 students with last names H to L.
So 5 is prime. So I mean it has to be 5 and 1, right? Now decide on the sign. Right. And how do you know that's so quick? If the middle term is positive, then the bigger number has to be positive. So plus a 5 and a minus a 1. And then re-sub back in. We know that y is x squared plus 5. And then y is x squared minus 1. Now, only the brightest of the bright will realize I gotta keep going, right? So don't forget. What does that factoring flowchart always say at the bottom? Check for more, right? Always check for more. So how are we going to finish this one off? X a plus a 1 and x a minus a 1. Good. Okay, now up to the next one. You can see x to the 6. So let's use half that. Let's let a equal x cubed. So then we'd have x cubed squared, because it has to have that pattern, minus 9x cubed plus 14. We were going to let x cubed be capital A, so we have a squared minus 9a plus 14. We've seen this one already. It's 7 and 2. This time they're both what? To make a positive 14, you have to have them both negative. Now just put that x cubed back in there. So these can be quite challenging if you don't practice them. Like, it's just one thing to watch me do it. It's another thing to actually practice. And just by looking at your homework, a lot of people did their homework, and there was a test on Friday, so I'm quite impressed. Okay, so class example 2A looks the same to me, except there is a little subtle difference. What's the subtle difference? Here is A not 1, so we have to use decomp. If you look on the previous page, what were all these A values? 1. So all I had to do was use inspection. Inspection is just where you think of the two numbers and then once you got them, you write them down and you're done. Like for 14, 7 and 2, and you're done. But with A not 1, you have to think of those numbers and then decomp. Okay? So these are kind of nasty. I wouldn't even do a substitution on these. I would just find, I'm going to put little notes for you. I wouldn't do a sub on this, even though the book tells you you should. Don't sub. Find two numbers, and then decomp for grouping. 4-term grouping. So with those notes there, and then my examples, it should make sense. Okay, so for the first one, what are we looking for? AC is negative 24, and B is negative 5. So what are the two magic numbers there? 8, 3. Good. Which one's negative? The bigger one. Good. So now we can break it down. So would you put the 8 first or the 3 first? Why? Because 8 would go with the 4? Does it matter? Good. Doesn't matter. So minus 8x squared and then plus 3x squared minus 6. Because minus 5 would be the same as minus 8 plus 3, right? That's what we call finding the two magic numbers and then decomp. Now we got to do the 4-term grouping. So what do I mean by 4-term grouping? That's this stuff, where you find these GCF pairs. Okay. So the GCF in the first pair, 4x squared. Good. And when we do it this way, you don't even need a substitution. It's just going to work out for us. Take out a 4x squared, you get x squared minus 2. Take out a positive 3 and you get, now the x squared minus 2 is in common. And then 4x squared plus 3 is the leftover. So that one's actually almost identical, just with higher powers. Do you agree? And no substitution on that one. All right. See that black ink there? I was going to try and blow it off my screen like this, but it's on the screen. All right, so taking a look at this, which term is like our ax square? Which is the x square? Is it the b or the a? See the b square and then b showed up again? Or is it the a square? Does it matter? Yeah, on this one, it doesn't even matter. So what I would do is I would just think of the magic numbers that work, find the two numbers, decomp, and then 4-term groups. All right. Is there a GCF, by the way? No. Remember, always check for that GCF at the beginning. In this case, we don't have one. All right, so what's the AC value? And let's just think about the numbers. And I think the letters will work themselves out. So 2 and 99 make, thank you, 198. And then the B is 31. Okay. So here's a little tip. The sum is negative, but the product is positive. So what does that tell you? Both numbers have to be negative. So what are these two numbers? How do you know that so fast? So he says 22 and 9. So how did you do that so fast? Just try it on the calculator a bunch of times? Okay, good. Okay, so this is what Dawood was putting on his screen as I was talking. He's just trying factors. And why is he trying 6 and 8 and 9? I mean, he's probably tried 2 and 3 and 4 and 5 already above, right? You guys see that? And then he's looking at these numbers, and he's like, okay, if I get a decimal, obviously it doesn't work. Okay, but then he, like 6 worked, so why didn't he use 6 and 33? Because it won't get you to 31, right? But 9 and 22, it does, right? Okay, good. Get that out of there. So it was 9 and 22, correct? Okay, so that's the two numbers we're going to use to break down this middle term. So just rewrite 2a squared b squared. Now the middle terms are a, b's. So do you want to put the 22 first or the 9 first? I'm going to put the 22 first, because 22 kind of goes with 2 and 9 kind of goes with 99. Ultimately, it won't matter. So a minus 22ab and a minus 9ab and a positive 99. Now just a word on sign. Look at the orientation. It goes plus, then it goes minus, and then it goes minus, and then it goes plus. So what's the problem? One of them you have to factor out a negative. So typically do that on the second group. So what's coming out of the first pair? A 2ab. Okay, and then you get ab minus 11. Now we're going to take out a negative, and we can only take out a 9. So then you get ab minus 11. This is a weird one. ab minus 11 in a bracket, and then you have this 2ab minus 9 in a bracket. So they're talking about east and how east is about to start, and we're only on class example 3. So let's pick that up tomorrow, class example 3. Now for the homework for tonight, I would review lesson 2 because you're going to have a quiz on lesson 2 tomorrow. We'll just do one quiz because we didn't get through all of lesson 3. So we'll just do the one quiz tomorrow. And then for your homework tonight, I would just try this first page. Is that okay? One page, please, all. Let's just do this in chunks. Let's get this done. So that's only 10 questions, so that shouldn't take longer than about 30 minutes at home. So good luck with your factoring, and you can check that Seesaw app for your East offerings. Matters.